Operating systems are like the invisible hands inside our computers. They are the fundamental software that makes everything else work. Without an operating system, our computers would be useless boxes of electronics. They bridge the gap between the hardware and software, allowing us to interact with our computers and run the programs we need. Imagine trying to talk to someone who doesn't speak your language. That's what it would be like trying to use a computer without an operating system. The operating system acts as a translator, allowing us to communicate with the computer in a way we understand. It provides a user interface, which can be as simple as a command line or as complex as a graphical interface with windows, icons, and menus. The operating system is responsible for managing all the hardware and software resources of the computer. This includes the processor, memory, storage, input-output devices, and network connections. It ensures that all these components work together harmoniously, allocating resources as needed and resolving any conflicts that may arise. In essence, the operating system is the foundation upon which all other software runs. It's the unsung hero that makes our digital lives possible. Operating systems are responsible for several core functions, all of which are crucial for the proper functioning of a computer system. These functions can be broadly categorized into four main areas: process management, memory management, device management, and file system management. Process management involves handling the execution of programs or processes. The operating system determines which processes get to use the CPU, for how long, and in what order. This ensures that multiple programs can run concurrently without interfering with each other. Memory management focuses on allocating and managing the computer's memory. The operating system keeps track of which parts of memory are being used and by whom. It also provides mechanisms for programs to request and release memory as needed. This is essential for preventing programs from crashing due to memory conflicts. Device management deals with controlling the various hardware devices connected to the computer, such as printers, scanners, and network adapters. The operating system provides a consistent interface for software to interact with these devices, abstracting away the complexities of the underlying hardware. File system management involves organizing and managing files and directories on storage devices. The operating system provides a hierarchical file system structure, allowing users to create, delete, move, and rename files and folders. It also handles file permissions, ensuring that only authorized users can access sensitive data. The earliest computers, developed in the 1940s and 50s, did not have operating systems as we know them today. Programmers interacted directly with the hardware, often using machine language or assembly language. This was a tedious and error-prone process, as even simple tasks required writing complex instructions. The first operating systems emerged in the late 1950s and early 60s. These systems were quite rudimentary compared to modern operating systems, but they represented a significant step forward. One of the earliest examples was GM-NAA-IO, developed by General Motors for the IBM 704 computer. It introduced the concept of batch processing, where a series of jobs were submitted to the computer and processed sequentially without human intervention. Another pioneering system was the Compatible Time-Sharing System, or CTSS, developed at MIT. CTSS allowed multiple users to share a single computer simultaneously, each with their own terminal. This marked the beginning of time-sharing systems, which would revolutionize the way computers were used. Time-sharing systems, which emerged in the 1960s, represented a major breakthrough in computing. Prior to time-sharing, computers were primarily used for batch processing, where jobs were executed one after another in a predetermined order. This meant that users had to wait for their jobs to be completed before they could see the results, which could take hours or even days. Time-sharing systems changed all that by allowing multiple users to share a single computer simultaneously. Each user had their own terminal, and the operating system rapidly switched between users, giving each a slice of processing time. This created the illusion that each user had their own dedicated computer, even though they were actually sharing resources. One of the most influential time-sharing systems was Multics, developed jointly by MIT, Bell Labs, and General Electric. Multics introduced many concepts that are still used in modern operating systems, such as a hierarchical file system, dynamic linking, and online reconfiguration. Although Multics itself was not commercially successful, it heavily influenced the development of Unix, which would become one of the most important operating systems of all time.